Today we're going to be talking about code smells. What is a code smell? Martin Fowler says code smell is a surface level indication that usually corresponds to a deeper problem in the system. The goal for today is we're going to be going over 5 categories of code smells. Now, code smells may be categorized differently between organizations. This is one that I found over on a website called Refactoring Guru. Code smells are not an indicator that there is, but as it says that there usually is. So anyways, yes, my desire today is just to talk about the high level awareness. If you have any questions about anything, wow, am I just a broken record? Anyways, so let's go ahead and get going. So let's just go ahead and start talking about the different types. So one of the types of code smells, bloaters. What is this? This is a section of code that's large and unmanageable. A couple of ways that you can identify this is just seeing that you have too many lines of code, such as the long method bloater. The guide on refactoring says 10 or more lines. You'll be able to identify that there's too many because just visually it's going to be really large. How do you fix a long method? Typically just extracting code. You'll be able to find different pieces of the code, different sections of the code that maybe correspond to another reusable method. We'll talk a little bit about duplicate code later. But there are different ways that to take care of long methods. Sometimes it's inevitable. Maybe it's just building up a class, but maybe there are other ways that you can break that down. Another indicator of a bloater is long parameter list. As part of clean code, Uncle Bob talks about this a little bit. And one of the things that Refactoring Guru says as an indicator is you have 3 or 4 parameters for a method. Again, this is not the only way to correct a long parameter list, but a very common way that I tend to solve it myself is by introducing a parameter object. Parameter objects also can be reused within multiple methods, especially if you're doing some sort of chaining. Be able to get information around in other areas. If you have the class and you're pulling information out of the class, putting in the parameters anyways, may as well just pass that object just as the class itself. Other types of bloaters that you could be looking into are large classes, primitive obsession, and data clumps. So again, I'm going to keep pimping off Refactoring Guru. Again, that's one of the nice little ways that you can do some research on code smells. Next type we have, object orientation abusers. So for this one, these are smells that are incomplete or incorrect application of object-oriented programming principles. One of the examples on this one is alternative classes with different interfaces. It says on here 2 classes that perform identical functionality. Wow, I spelled that. But they have different method names. So sometimes this could happen if there was a class that was existing that performed a functionality and somebody else wrote a class or a helper method or helper function that did the same thing, or again, something that's very similar. And they just didn't recognize it. So how do you resolve this one? So you try and minimize the duplication by combining the commonalities. So you'll identify the old class, you'll identify the new one, find ways that you can put it together. And sometimes you could even delete one of the classes, which is really cool. Sometimes you can throw an interface on top of it and you can have those 2 classes, but you could simplify things much different. Other types of object orientation abusers that you can identify, reused bequest, switch statements, or temporary field. Next one we're going to go through, change preventers. So this one is interesting. So it's the idea that you make a small change in one area and you also have to make changes in other areas as well. So for this one, we have divergent change and shotgun surgery that we're just going to hit on real quick. One of them is when you change a method in a class, you identify that other methods in that same class need to change. So what's the best way to do that? You extract the behavior from the class. But that can also lead to shotgun surgery, where you're extracting too much and you're spreading it out in a way that when you change one class, you have to also change another one. And so that's shotgun surgery. So how do you resolve that one? You put them into a single class. So there is a nice median between the 2. Another example of a change preventer, parallel inheritance hierarchies. So we'll hit on the next one. We're kind of rocking quick. We'll hit on dispensables. Biggest thing for this one is that this code is usually pointless and unneeded. As it mentions on here, when it's deleted, it just makes it cleaner and easier to understand, but it also does not change the functionality. Typically, some of this stuff is going to be duplicate code. You delete code for this one, but you also have to replace it with a method. Now, when you're deleting code, you're also finding the reason you delete code is because you're finding multiple sections that have similar functionality or the same code, create a similar method, and now you have a reusable method. So you are deleting code, but you're replacing with the same code and the same functionality, but you're able to reuse in multiple areas. We also have speculative granularity, which comes down to the idea that something just is not used. Maybe it was built, and the anticipation is that in the future it's going to be used. But the big question that we have to ask ourselves is, why do we need it now? Now, that could be additional parameters that you're adding on something. It could be methods. It could be entire classes that just aren't used. And the good thing is, within our IDEs nowadays, I'm very much a user of Writer. Writer grays out all the parameters that are not being used, or I say parameters, variables, methods, classes, anything that's not being used. So it provides some hints on these code smells that we're going, but one of my favorite ones is just not used code. Just gives you a little gray, you hit a couple buttons, it's gone. And guess what? Nothing broke. Some other dispensables are comments, data class, dead code, and lazy class. And I think I mentioned dead code a bit. Something that was there, was being used, it's no longer being used. All right. And we have couplers. So for this one, we have excessive coupling between classes or excessive delegation. We're going to hit on the excessive delegation with the middleman. So for this one, it's the use of a class with one purpose, and that's just to delegate work to another class. So it's the idea that maybe at one point it was doing more, but now it's not. Maybe that functionality has been moved further down. Maybe it's been moved further up. But the idea is it is just calling a class. So for this one, a quick treatment is to remove the middleman and call the class directly. But maybe it's not that simple. So there are additional treatments on how you can resolve. Everything that's on here from a treatment perspective is your mileage will vary, or excuse me, your mileage may vary. So if we say delete and that doesn't work, one thing I recommend taking a look at, again, going to Refactoring Guru, they do have some nice suggestions on how you can resolve some of those. Other examples of couplers are feature envy, inappropriate intimacy, incomplete library class, and message chains. So what do you do next? So at the good old Boy Scout rule, I was told that maybe this isn't the same rule that applies today, but Boy Scouts used to say, whenever you go to a campground, leave it cleaner than when you found it. So that's talking about the idea that if you go into a section of code, you're working in there, that's the area that you want to make sure that is just a little cleaner than when you left. So if you see some of these variables that aren't being used, if you see some methods, if you see some tight coupling, if you find some duplicate code, that is the appropriate time to make those changes. I would not recommend having a clean campground and going and cleaning a separate campground that you were absolutely not part of. That really gets into scope creep, and that's not something that you need within your project. So the other thing is with new code, making sure that if you're building something, I like to live on the idea that I want to make something work. So I'm going to write code that's okay. And then I'm going to make something right, which is where I start applying some principles, some patterns, just to make things cleaner. And then I try to optimize, and you optimize as you need to. So definitely for this, any of these code smells that have been introduced today, a lot of the awareness for the terminology of the naming on those, you may not have known, but as you get experience and as you get past the stage of just learning syntax and you start learning different principles and patterns, you just start, I'm trying to look for the word, but you just, without even knowing, these are things that you identify. But being able to add some awareness on this, Your, we'll just say lower level developers that are maybe still looking into syntax and whatnot. Some of these principles, some of these practices are nice for them to be aware of. Good things for them to look at in pull requests when they're, again, going in to maintain additional code to go do some refactoring, anything. It's a nice way for them to build on their craft. So as Martin Fowler said, any fool can write code that a computer can understand, but good programmers can write code that humans can understand. So as with everything, not always for ourselves, but it's also for the individuals coming after us. So this is just one way of cleaning up your code, not only your code, but code that of others that have come before you, to make it just a little simpler for others to maintain after. So that's all I have. I have a couple links on here, which clearly you can't click. Maybe I'll get this PowerPoint out there. Maybe I'll see if someone can pretty it up. Clearly, I'm not a UI UX designer. I actually got the really nice LT templates, but I'm like, I don't know how to use these. It's cool. So I'll get this out there. Martin Fowler has a nice article on code smell, but also in Martin Fowler's book, Refactoring, he does have a chapter on code smell where he goes through all of this alongside Kent Beck. So go take a look at that. And then Refactoring Guru, which I used as my guide and of course copied a lot of information from because it was really easy and simple. So cool.